Hi folks, welcome back to another lesson, and today we're going to move on and look at the speed of sound. Okay, so state the speed of sound and the speed of light, describe an experiment to calculate the speed of sound. Now, as always, we're not in the classroom, so we can't do this, but we are expected to know how to measure the speed of sound, so we can look at doing this when we get back into the classroom. So just to remind you, a wave is a phenomenon that repeats regularly. And remember all these different parts of the waves. We've got the crest, we've got the trough, we've got the wavelength, and it can be measured in two different ways. We then have the amplitude, which again can be measured in two different ways. So these are all basic things that I expect you to remember about a wave. Now, can you try naming the following bits? So pause the video and have a wee go of it, and then I'll tell you the answers. Okay, so hopefully you got the following. Okay, so um, A is the wavelength, B is the amplitude, and C is the trough. Okay, so moving on now, and we're going to look at speed of sound first of all. So the speed of sound is 340 meters per second in the air, and the speed of sound in water is 1,500 seconds. So could you copy these two down? Now, you're not expected to remember these. They are provided for you in a data sheet, okay? But hopefully you will at least remember this one because we're going to be using this one quite a lot. And finally, the speed of light is 300 million meters per second. And so you can see here that speed of sound is quicker in water, but the speed of light is the quickest of the three things mentioned here. And a wee point here, because the speed of sound is quicker in the water, if you're in the swimming pool, you will hear sounds much quicker than if you were standing at the edge of the swimming pool surrounded by air. And that's because sound travels quicker in air. With lightning, you should always see the flash before you actually hear it. Okay? And that's where we come up with this phrase, we always see it before we hear it. Now, you might say, well, why is it that quite often I hear the thunder and then I see the lightning? Well, the reason for that is because the thunder is actually caused by the lightning, but the lightning might be taking place higher up in the skies, up in the clouds where you can't see it. So what I've got here, folks, is a few videos just to show you what happens in a thunderstorm. And there's a wee video here, I believe, which is showing you at the top there, which is talking about the speed of sound and what happens when you break the sound barrier. So I'll include these so you can watch these videos yourselves. Okay, now let's get straight into the experiment. So I would like you to copy this wee bit here so you've got a wee record of the experiment. So to measure the speed of sound, we've got two microphone speakers, and these are connected to Alba, and they're separated by a distance of 1 meter. And all we do is we clap our hands, and the sound of the clap will travel from one speaker to the other one. When it hits the first speaker, it will tell Alba to start timing. When it hits the second speaker, it will tell Alba to stop timing. So we've got the method here, which I've summarised for you, so please copy that along with the aim, diagram, methods. So sound from the hand clap will travel past the two detectors. These will measure the time it takes to go from one detector to another, and we can calculate the speed of sound using our good old friend, speed is equal to distance over time, where the distance is 1 meter, and the time is the time for the sound to travel from one detector to the other one. And obviously, we present our results in a table. And what we would do is we could either calculate each of the sounds results of the speed of sound and then work out the average, or we can calculate the average time and then work out the speed of sound as an average. Conclusion, what is the answer to your aim based on your results? Well, hopefully, if we do this experiment, we should get our answer to be around 340 meters per second. Okay, now the final one is the one we could do outside, and it's always nice to try and do things in two different ways because then you can compare them and see which way is better, or see if you can still get the same result even if you try and do it a different way. So this one we'd have to go outside. You have a loudspeaker and you have the timer, and we measure the distance from the loudspeaker to the timer. So the distance between the two pupils is measured. One pupil shouts into a loudspeaker, The second pupil measures the time it takes for the shout to travel from the first pupil to the second pupil. We then measure the speed of sound using distance over time. And again, I would like to copy this one up. So I know there's a fair bit of writing, but both experiments are ones that you should be familiar with. So that's why I want to take a note of those. And that's how we measure the speed of sounds in school.